You're going to write some of these in the other form. If it's given in exponential form and you want to write it in logarithmic form, you can kind of just go by, if you see the numbers, you can just go by intuitively knowing what it is. Or you can work with it just like an equation, any other equation. Since there's an equal sign there, as long as you do the same thing to both sides, you can change it into another form. Again, not trying to insult your intelligence, but I want you to connect it with what you learned in grade 6 or 7 or 8 or whatever. If you wanted to change that to a different form, right, or let's make this a y to make it slightly more different, you could subtract 2 from both sides. That operation on both sides will change it into this form, right, y minus 2. Saying x equals y minus 2 is the same as saying x plus 2 is y. Those are two different forms of the same statement, basically. That's what we're doing here. As long as you do the same function, the same operation on both sides, you can change it. And the reason you choose this one is to cancel that out, right? Those cancel out. If you want to change this around, what you could do is the inverse of this, right? The inverse of that 5 to the power of is log base 5. So if you want to think about it this way, you can think, if you're ever not sure and you can't just write it right away, you can think, I need to do log base 5 of this side and log base 5 of this side. I don't really need the brackets, but whatever. If I do log base 5 of both sides, this will cancel out. That cancels out. I just have a 4. Log base 5 of 625. You can change an equation one form to the other by using inverse operations, right? Like this thing here, log base 3 of 81. You can do anti-log base 3, which is basically just writing a big 3 underneath it, because that cancels that out. 81 is 3 to the 4th. There's nothing wrong with just intuitively writing it by knowing what a logarithm is, but you should be able to do both things. Using a logarithm as an operation you can use on an equation is important. This one is going to be negative 3 equals log base 4 of 1/64. Again, you could do log base 4 of both sides. Here you would do, if you're trying to do that one, if you did if you did logarithm base p on both sides, because that's what the base is, log base p of n is log base p of p to the w, or in other words, just w, right? That's that one. The other ones I'll write down, you can just check for yourself, but understand you can get them by, if I did k to the power of both sides, I'd have k to the h equals t. This one says evaluate. It doesn't say express it in a different form. There's no equal sign there. If you want to write what that is kind of in simplest form, you could make it equal. You could say, I'm going to make it equal to x, and then treat it like an equation if you want. That's a strategy you can use. Even if it's not an equation, you can make it an equation by putting a variable on the other side and then changing it around if you wanted to, because then you could do this if you wanted to. That would cancel that out. So you'd have 3 to the 5 equals 3 to the x, so x is obviously 5, so what you're looking for is 5. Or you could right from the start just see log base 3 of 3 to the x. These are inverse operations, that and that. They cancel each other out. Right? Doing log base 3 of 3 to the power of is like saying square root of 2 squared. They cancel each other out, this operation and this operation. So this cancels out, you just have whatever it was there, it was a 5. It's a 5. Okay? These last couple here. This one, if you're trying to find the logarithm of something, if you can write it as a power of whatever the base is. Root 6 is like 6 to the 1/2. Okay, log base 6 of 6 to the 1/2 is 1/2. Y equals 5 to the x. If you want to write it in logarithmic form, you could do log base 5 of both sides. Log base 5 of y is x. The other stuff on here, I'll let you think about that sometime. You can ask questions individually if you want, if you're not sure. If I show you how to do this question, you're never going to see another question like it. At some point, maybe we can do that once more people have tried it. But there's kind of a summary at the bottom. They're base 10 logarithms. And in any base, for this statement, n is log of b. n is the exponent necessary in order to express b is a power of 10. Okay, like 10 to the n equals b. For this statement, it's exactly the same thing, except it's not a 10, right? It's not a 10 there, it's a whatever that number is. It's exactly the same statement though, right? N is the power that you need to express b as a power of whatever a happens to be, right? Whatever this is, whatever this base is here. So instead of that, you have that. A logarithmic function is the inverse. They are inverse functions, inverse operations. Each one undoes what the other does. Okay, so again, 10 to the x, log x. Those are inverse functions. They cancel each other out. Okay? At some point before next time, you should do some of this practice. We're going to look at the third tutorial right now, but you should do some of that before next time. We're likely not going to get the third tutorial finished. So certainly, if you haven't done practice for 1 and 2, you should do that before next time, I would say. We do have a pretty good chunk of time, though. You want to do the harder questions right now? I want people to try them first before we talk about them, so maybe we'll take them up later.